of background first, and the background is what is the actual problem with asynchronous. Well, even though the brain, is a massively parallel computer, it's really not wired for asynchronous at a high level. Yes, sir. Oh, okay, sorry. And yet, following a step is something very easy that anybody can do. Yeah? Can we just not do asynchronous? Why can't we just stay, with the sequence and step and stick with that? Well, sadly, it's not possible. Asynchronous is a fact of life, and where we see the progress in the industry is that there's more CPUs, there's more core, there's more cloud, there's more people, there's more things to interact with, and there's just more data everywhere. So we need to be asynchronous in order to be able to interact with all those things. And some people say that functional programming is a solution. And the question is it really a solution for everyone? And can actually functional programming without side effects be used effectively? And it's easy to optimize a solution based on functional programming as long as we don't have the side effects. But of course, we need the side effects some way in order for functional programming to be interesting and able to perform calculations. There's two main patterns with asynchronicity, and so those old enough will remember those two interfaces: serial port, parallel port. Now it's all USB nowadays, or even Bluetooth. There's no more connection. But that's what we used to deal with computers, in the olden days. So the first type of composition of asynchronous steps is the sequence. And basically say I want to do step A, and then B, and then C, and then when I'm done with those three asynchronous steps, I want to keep going with my synchronous processing. The way to do that is serializing those calls and waiting for the first task to be completed, and what you end up is a series of callbacks. And what happened with that is that, of course, the more steps you want to sequence this way, the more callback context you will get, and at the end of the day, it's starting to get very, very complicated to debug, to understand, and to reuse. That's what people call callback hell, and that's what Promise is trying to get away from. I'll show you a bit of that later. Is there a way to actually improve on this piece of code? And one way to improve on this piece of code is try to remove the series of contexts which are aggregated with one another. And one way to do that is to have flat callbacks. And so how do you do that? Is you start at the bottom and you say, I've got a callback just for the first step. And you define this callback by saying, I'm actually going to call the B task, and I've got a callback which captures the value of the first callback. And when you start doing that, you say, what's going to be the next step is that you're going to have to be a callback that's even more complicated. And of course, this one will have the C callback, which will have to capture the previous two values, and you'll have to return, the callback itself will return the functions that just doing that and capturing the three values. So if you care about knowing the actual techniques used to be doing that, it's called currying. What we're doing is that we're partially applying the callback, and that's a functional programming construct that's very useful. All right, but that's not really better. Like having the flat callback construct and the currying of the callback doesn't really solve any problem, because the problem is not really the nesting, even though the nesting is something you want to get rid of. The real problem is the chaining of those sequence of steps. And with this chaining, with the flat callback or the nesting of the callback, we still have dedicated callbacks that can't be reused. And it means that your code is not dry. That's the real problem with the sequencing of asynchronous steps through callbacks, is that you can't reuse those callbacks in your code later on. So the second pattern is, of course, the parallel composition of asynchronous tasks, where you can run them in parallel. And so you've got three tasks, you run them in parallel, and then you want to synchronize them and keep doing your synchronous processing. Now the heartbeat is no more the sequencing of the task. The heartbeat there is to do the synchronization at the end. How do you know that the three steps are finished? One might be very fast, one might be very slow. They can terminate in any order. How do you do the synchronization? One terrible way of solving this problem is what I've shown there. You start the three tasks, and then you check if they're completed. And if they're not, well, you just wait for a bit of time, and you keep checking. So please put the comment, do not copy-paste this piece of code. That's not the proper way to do it, but I've seen that over and over again for trying to synchronize parallel task execution. So don't do that. So what is the solution? Well, the solution is the promise construct. That's what I'm going to talk about now. It actually started a very long time ago, in 1976. So people have started talking about the promise construct and future values and deferred and whatnot back in 1976. Back then, it was all about RPC over the network. So of course, network was not TCP/IP; it was token ring or whatever, you know. What is it? What is it about today? It's about race call over the network. Yeah, it's really like plus ça change, plus c'est la même chose. It's my French quote of the night. Sorry, I won't make any more. But really, that's what it is about. Try to picture 1976. You know, that was when that was the top of the range computer you could get. Yeah, that's a Cray 1. Yeah, the most powerful computer ever in 1976. Now, to get the power of your iPhone that you got in your pocket, that's about 14 of those guys that you will need. That's a bit heavy to carry around. So let's make an analogy, okay, for the promise concept. And you've got a couple of eggs in the chicken coop in the backyard, and you don't really know what's going to happen to those eggs. You hope that if everything's successful, you got the right transport and the right procedure to prepare them, then you'll end up with a couple of fried eggs and yummy breakfast. Great. Now, if something goes wrong, you know, transport is not very reliable or whatever, you end up with a cracked egg. Now, if you put a bit of formalism on this analogy, you have a pending state at the top. You've got your future value. You don't really know what it's going to hold. If it's successful, you get your yummy breakfast. And if it's not, well, you're still very hungry. And that's what the promise concept is all about. So if you understand the diagram, you've understood the promise concept. Now, of course, there's a bit more to it than that. A future value is a value that's not there yet. And yet you want to be able to reason about it. And another way of saying that is it's an asynchronous access to the result of an operation that it's ongoing or completed. And that's a pretty powerful concept to be able to say that you can get the value in the future, or you can get the value now if it's already been computed. And that will be the exact same API to access both cases. And if you think about it, that's one of those callbacks arguments we were looking at right before. And those callbacks arguments are the future value we're going to deal with now. And so that's why my talk is called the future is a promise, because really the future value is actually the coming from the promise construct. Yeah, I'm not trying to predict the future or anything. And so yes, we call that a promise. And they're really good for composition, for either serial chaining, for parallel execution in a dry, fluent API where you can reuse your promise construct, and that's how we're going to look at. But if you think about API and JavaScript, there's really two things that don't go very well together. There's 10,000 libraries out there, and the promise concept started in some obscure libraries and when moved to Dojo.js. Then there's some people from CommonJS that came up with a specification called promise/A. Then jQuery 1.5 started partially implementing this specification, and then some people were not happy with the implementation from jQuery and started the promise A plus spec, and then there was this framework called Q that actually implemented the specification. So before showing any real code demonstrating the promise concept, we have to select an implementation. So I started with the jQuery implementation because everybody has access to jQuery somewhere, always have to deal with jQuery at some point in time. And so really, all there is to know about the jQuery API for promise is the ability to be able to create what is called a deferred object, which is like a promise factory. So I could have put a chicken there, and it would have laid an egg. That's your deferred object that would create a promise. And you can do mainly two operations on the deferred object. You can resolve with a value. You've got your fried eggs. Or you can reject it and say, well, the egg is cracked on the ground, so I can't do anything with it anymore. You can extract a promise object from the deferred. The promise object is like a read-only view on your deferred, and this read-only view is the one you can pass around for further processing, and you can then query the state of this promise. It can be pending, resolved, or rejected, like the eggs in the diagram. And you can then compose it in a serial way using the then construct, or you can compose them in a parallel way using the when jQuery construct. And you've got a number of other ways to register callbacks on the promise: done, fail, always, and progress. Always one is probably the most interesting. We say, whatever is the result of the computation, I want to execute this piece of code. And the progress one allows you to register progress events, but that's on the side. Okay, what can you do once you've got this construct? The first thing we can do, which looks a bit silly, but we'll see later how we can actually use that, is wrap a straight value into a promise. And it's like putting back something into the eggshell. Imagine you've got 42, but you want to be able to compose 42 as if it was a promise itself. And so you can just use this wrap construct I've written there. What you do is you create a new deferred, you resolve it instantly with a value, and you return the promise. And once you've wrapped 42 into this construct, you can use it and compose it as any other promise you would think of. jQuery actually provides this for you. When you put a straight JavaScript value, native value into the when function that's not a promise, JavaScript will wrap it for you automatically. Which means, like, if you put the result of a function into the when construct, you can then chain it as if it was asynchronous. Something interesting you can do as well with deferred construct is wrap the set timeout function. I don't know about you, but the set timeout, I never really liked the signature of this function. And this allows you to say, let's build the deferred, and let's make the deferred resolve once the timeout has expired. And then I return the promise out of that. And you can see it's always the same pattern in the wrap, in the wait. You create a deferred, you return a promise, and in the middle you do something that will reject or resolve your deferred, either synchronously or asynchronously. It doesn't really matter. And so what you can do once you've wrapped your set timeout into the deferred is you can write something like that, which is very readable in my mind, much better than the set timeout function. Yeah? Wait half a second, then keep going. So if you go back to the analogy and you want to think about negation, and what is negation is saying, well, what was resolved is now rejected, and what is rejected is not resolved. So bear with me, why we want to be able to do that. And the implementation of that is very, very simple. And as you can see, it's like 3 lines, always the same pattern: create a deferred, return a promise, do something in the middle. What it says there is that that's okay. Yeah. So I've got my promise, that's the input parameter, and then when my promise is finished, if it's resolved, then reject the current deferred, and if it's rejected, then call the resolve on the deferred, and that actually negate the promise that was sent in. Now, or every programmer knows that A or B is the same as not A and not B, and so hopefully you see where I'm going with that. You can implement or of promises. And so if you want to have A or B, what you do is you negate the when of negate A and negate B, which is the exact same equivalent of what I've written there. So the when, jQuery when, is actually an AND of all the promises you pass in as arguments. And of course, we can generalize that to any number of arguments. Let's go one step further. And you just have to negate all the arguments and then apply the negate to to the bunch. Of course, there's a nicer way to write that, and by applying a bit of functional programming things, you cast the arguments, which is not really an array, into a real array by using the slice apply trick, and then you can, on the args, use the map function, which is available in the more recent version of JavaScript, to the negate function, which means apply the negate to all the elements of the array and return an array out of that. And once you've got that, you can just use the apply on the when with an args argument. Okay? That's just a bit of functional programming trickery for you. All right. So the jQuery API, simple and consistent, integrate with all the existing API in jQuery already, and most asynchronous tasks in jQuery would return a promise nowadays. So starting with jQuery 1.8, the API started to really move towards the promise construct. And of course, Ajax call in jQuery return promise. An animation can be coerced into a promise if you go to the HTML element where the animation is operating. You can actually extract a promise from that, and it will get resolved when the animation is finished. And any other values that are not asynchronous tasks will get instant resolve through the when wrapping. Now, if you look at the divergence from the promise /a spec, it was always more an inspiration than a true implementation. The big change was in jQuery 1.8, where the pipe method was changed to then. So I'm not going to explain why it was very important. I've got links at the end that explain, and there's like a 10-page long bug report about people complaining about it being broken, and that's a big drama and everything. But really the big difference about the jQuery implementation and the promise /spec is about the exception handling. In jQuery, exception thrown will stop any processing step in the promise chain. Whereas in the promise /spec, it says that an exception should fail the then construct with a callback throwing an exception. And there's a good reason for that. In jQuery, and so why did they build another spec out of the first one? So the A+ spec actually specify very strictly the exception handling mechanism and provide a very strong test suite against this particular specification. And of course, this test suite is failed by the jQuery implementation because that was the point of the A+ spec. It's saying, well, jQuery is not good enough. Where wanted to go? Oh, yeah. And so the error handling is, the real question about which one is right or wrong. Like, that doesn't really matter, but it's really more a philosophy about do you want to throw or not throw exceptions? And in Java land, this is something that has been animating mailing lists for decades about, should we have checked exception or unchecked exception? And that's basically the same debate that they're having there. And the question is, are exceptions user generated? Like, in your own code, do you really want to throw an exception, or do you want to have a piece of code that by default, in an expected way, will throw an exception? Doesn't seem to make a lot of sense. And basically what it means is that jQuery treats a thrown exception as a bug, and will just stop right there and let the exception bubble up. Whereas the promise /a+ spec says, if there's an exception, maybe it's a bug, maybe it's user generated, but it should just fail the promise and be done with that. When you look at the jQuery code base, you can see there's about 10,000 lines of code, and there's about 5 throw statements in there, which is not a lot. When you look at the Q code base, there's got about 1,500 lines of code, and they've got 10 throw statements, which means they've about 10 times more throw statements than the jQuery code base altogether. Yeah, so that gives you an idea about the Q code base thinks that throwing the exception is actually okay, whereas the jQuery code base says exceptions are dangerous stuff, they're bugs, we're not going to do anything with that, we'll just let them bubble up. All right, let's look at the Q implementation. They've got a pretty logo, yeah, inspired by the JS one, and it's fully A+ compliant, of course, that's what the framework, actually the guy who wrote the Q framework participated in the A plus specification as well. And the syntax is very, very similar to the one in jQuery. It's all the same construct anyway, so you've got A, then B, then C, then keep going, so exactly copy-paste from the jQuery implementation. Parallel is a bit different. You do Q all, and you've got an array of promises there, and then keep going. Here is another example coming from the Q documentation, and that's quite an interesting one. You give it a promise and a millisecond, and it will run the two in parallel, and if the promise get resolved before having to wait for those milliseconds, then it will be successful. But if it takes longer to resolve the first promise than the number of milliseconds, it will just fail with an error. So it's not going to throw anything, that's just the return value. So it's not throwing the exception, it's just failing with this particular value. So that's an interesting construct to say, do this operation, but if it takes more than this number of milliseconds, just fail and forget about it. And that's very, very simple to read, to write, to understand, and to compose those promises together. What can you do? So that's also the negate and the or implementation in EQ syntax. But you can see that really, it's really the same pattern where you create a deferred and then you return a promise. And even though the syntax is a bit different, it's still exactly the same construct you can use with both implementation. There's a few extra in the Q library, because since it's a library that's just talking about promises and way to compose them, they've got some interesting wrapper function around object methods and about function, where you can just transform any of those in an object method or a function into a promise. You can just wrap them and use them for composition in the other promise construct we've seen. And also it's partially included in Angular.JS. So if you're doing Angular.JS, you don't have the jQuery deferred implementation, you've got the $Q, which gives you access to the Q deferred implementation. So the reason why the Angular guy didn't just include Q is they thought Q was too big and they wanted to keep Angular small, so they decided that it was more interesting to just strip down the bits they wanted and include that into Angular.js. And there's also people interested in mixing up jQuery and Q together, but it doesn't really mix that well. So if you want to do deferred and you're in jQuery, use the jQuery implementation. If you don't have jQuery, if you're Angular, use $Q, otherwise you can just use Q by itself. And so when you look at this construct, hopefully you've understood what you want to use promise for. It's to do parallel and serial composition of asynchronous tasks. And the question is, what comes next? What can we do next? So the first item there is promise as monads. And do anyone know about monads in there? A few? 3, 4, 5? Yeah. So the problem with monads is that it's a very complicated functional. Sorry?
It's a class.
It's a what? A class? Yeah. And it's a complex functional programming topic. And many people try to explain, and many of them fail, so I'm not going to try it tonight. There's actually a very good book called Functional JavaScript that came out this week, yesterday, and actually explain monads. They don't call that monads, they call it actions, but they actually got a very nice explanation on how you can use composition of actions, not monads, but they are exactly the same. So if you get your chance to read this book, go read it. You'll understand about monads more than whatever I could say about it. But basically, promise are monads in some particular way. So if you know what it is and you want to use that as a monad, then you can, with a bit of gymnastic on the API. What's really more interesting is that there is the DOM spec from whatwg.org, and they've introduced promise as part of the DOM specification. So they will come to a browser near you very, very soon. But the thing is that they keep changing the spec And so this screenshot is from the 6th of June, but if you take the version from May, the promise was called Future, and it was more inspired from the jQuery one than from the Q one. This one actually has a section on the error handling, and it's right on the Q implementation. So they're not really decided on which way they want to go yet. So it's just a spec for now, not a real implementation. What's very interesting as well is generators, which are coming in the next version of JavaScript, or maybe just the next one. They've been available in Firefox for a very long time now. They're available in Node.js today with this particular startup flag, and they define this function star and the yield keyword, which allows you to do some very, very smart construct, which basically you can implement promise without any kind of library or API. Straight out of the box. So you can do many things with generators, but that's like a topic for a couple of the talk, just on this one, and it's not really available yet anyway. Whereas promise you can use today in your browser. And I think I'm finished, and so that's all the reference I've been using to prepare this talk. Like everybody's talking about promise and about monads and about which one is the best implementation and so on and so forth. Well, thank you for listening. I hope you didn't.
Do we have any questions for Patrick? I thought we might. I'll scoot down the back. You were first.
Hi. So I really like how you spoke about promises. I use them all the time. Like how you spoke about promises as monads at the start. I'm curious, in the first couple of slides you said functional programming doesn't allow side effects. Haskell, Scala, Link is built on functional programming, yet clearly allows side effects. So what's your rationale there?
So functional programming can be used in many ways. Thank you. Functional programming can be used in many ways, and people talk about pure functional programming in saying you can apply functions which have no side effect whatsoever, and because you've cited all those programming languages, you probably know very well that in Haskell, for example, they use monads extensively to add side effects to pure functional programming. So I'm not going to explain that to you. Maybe everybody else wants to know about that. Monads are a way to actually add behavior to functions without modifying the functions themselves, and that's why it's a very important concept in Haskell. Scala is a bit of a different type because even though you can use Scala in a pure functional way, because of the object orientation approach, it's full of side effects, but just by that. And yes, you need side effects, but the thing that's interesting with functional programming is that you can build your application in a functional way, and again, the book Functional JavaScript really goes a long way explaining how you can do that. And yet, you can have, so what I was saying is that you can have the core of your application built using pure functional JavaScript, and then you can add the side effects as an end result of that. Okay? But I'm not saying that you should have no side effect. Of course, we need the side effects, but there's a way to build your application that is not relying on that. Yeah? Does that make sense? Any more questions? Yes? Okay.
Yeah, hi. Thanks very much. It's interesting in the debugging approach. I use a stratified JavaScript, Apollo, which actually builds its own wait for command, and so it's a verb additional to the JavaScript, so it makes it a little tricky to debug. Is this going to be able to do the same operation? If you're familiar with the stratified JavaScript.
No, so I'm not familiar with the stratified JavaScript on the wait for command. That said, my screen's gone. That's okay. You can actually write unit tests for promises very easily. And the fact they're asynchronous, you can use a library like Synod.js, which allows you to control the time each time you test. And so they're fully 100% testable construct, and if it's 100% tested, you don't really need to debug them. Yeah. So that's the point of it. But yet, you know, if you want to breakpoint in them, that's perfectly fine as well. Yeah. But
one more question.
the truth, that answer your question.
Yeah. Project. I only looked into promise very briefly when I've looked into them before, but the thing that really got me was, what if I want to have the result of A passed into B, and then the result of B passed into C?
Yeah, well, that's perfectly fine. That's exactly what it does. So I've cheated a bit in the presentation where I did the serial composition. I didn't explicitly say how you actually construct A, B, and C. And the idea is that A will be accepted with a value, and the value will be sent to the B function, which itself should return a promise. But what it does with A return value is not said in the slide, so you've got to make the construct yourself. And that's perfectly fine to do that. What you can do, and jQuery API is a bit more nice in this regard, because jQuery API, you know how jQuery has a standard where if you can give it an argument, you can give it a list of arguments, and it will just do the same with just every item of all the arguments. And so if you've got many arguments, you can just pass them along in all your callbacks and your promise return, and it will just chug along very nicely. In the queue implementation, it's not as nice. You need to do a bit more work to achieve the same. Not sure, does that answer your question? Or? Yeah?
You're on the mailing list?
Yes, I am.
If you've got any more questions, leave on the mailing list, up on Twitter, or we'll talk to his Twitter username soon. We all thank Patrick for coming tonight.